We're talking about velocity and acceleration today and tomorrow. Today we're focusing on rectilinear motion, which is basically movement of a point on a number line. The movement of a point on a number line. So it's just moving left and right. There's no other movement in these cases, in these types of problems. Remember from before we talked about position function, most of the time we have seen it as s of t for our function. Sometimes you're going to see it for these types of problems as x of t, because it's like moving along the x-axis. Sometimes it's written that way. But a lot of times we'll see s of t, but just so you know, x of t kind of means the same thing, position on the x-axis. Our velocity, remember that is the derivative of the position. And velocity takes into consideration direction. So when we have a positive velocity or a negative velocity, that means different things. We'll talk about that in a minute. But speed does not take direction into account. So velocity can be positive or negative, but speed has to be positive, and speed is going to be the absolute value of velocity. And then the last one here is our acceleration. Acceleration is the derivative of the velocity, and it's also the second derivative of position. So like I was just saying, velocity takes into account direction. When an object moves to the right in these problems on the number line, when it's moving to the right, the velocity is positive. So if we talk about a velocity that's positive, we know that the object is moving to the right on the number line. The velocity is positive. When the object moves to the left, the velocity is negative. Now, an object is speeding up when velocity and acceleration share the same sign. When velocity and acceleration share the same sign, and we're not talking about Sagittarius or Taurus or anything like that, it's when we have two that are both positive, velocity is positive and acceleration is positive, or velocity is negative and acceleration is negative. And if they both have the same sign, then they're speeding up. So if you think about it, velocity is positive, that means the object's moving to the right. If acceleration is positive, that means the velocity is moving faster to the right. So that's speeding up. Same thing if it's going to the left, velocity is negative and acceleration is negative. The acceleration is moving it faster in that direction. Now, if they're opposites, one's positive, one's negative, they're kind of working against each other. So that's when the object is slowing down. The velocity and acceleration have different signs. Displacement is basically the change in distance between 2 points in time. The change in distance between 2 points in time. So if we start off at a position of 5 and then end up at a position of 15, our displacement would be 10. And then the last one down here, average rate of change, is something we've talked about before. Average rate of change is just going to be equal to f of b minus f of a all over b minus a. Average rate of change, f of b minus f of a over b minus a. It's just the slope between the endpoints. And that gives us the average rate of change over that time interval. Now, some of the questions may ask, like, what's the average velocity? We would just be doing this with velocity. V of b minus v of a over b minus a. Average value of any type of function is going to be that. All right.